Today we're going to learn about operations and properties of matrices. This is the first part of 7-5. And matrices can be represented with a capital letter. So if you say something, I don't like this, if you say something like A equals A with a little I here, a little j here, okay? This means matrix A can be represented by A, and I and J stand for the row and column of that particular matrix, okay? For instance, Aij might correspond to the matrix A11, A12, A13, A21, A22, A23, dot, 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 until you get to some letter down here. So this might be A row 1, N, okay? And this might, and then eventually you get down here to row M, column N, okay? So if you're working on it, if you have some matrix like this, maybe I should make it more like this. So the I and J stand for the row and column. So if you say, you know, what is A12, there will be a specific element. Each one of these things in the matrix is called an element, okay? And so each entry in the matrix is an element. So
and that means like we have the same dimension, like equal dimension, like 4, 4, 5, 5, 6, 6.
MN?
Yeah, A.
No, it just means row M and column N. Okay, so this is the mth row and the nth column. Whereas this one, if I had one above it, right, this one would be in the, what's before M? L, the Lth row, and the nth column, like that. Okay? So they kind of use letters to indicate like that. Okay. So the other thing they talk about is equal elements, equal matrices. Equal matrices have equal elements. And so if you have some matrix, and it's kind of, if A equals B, and A equals, let's just say, -3, -3, -5, 2, and 0. And then you have matrix B, and you have entry, we'll call it B sub 1, 1, B sub 1, 2, B sub 2, 1, and B sub 2, 2, okay? Then B sub 2, 1 would have to be equal to 2. Okay, so all it says, if matrices are equal, then this element in this matrix has to equal that element in that matrix, okay? Not too complicated, okay? Okay, adding matrices. Question, you want me to slow down? You're okay. No? Marion, you want me to slow down? You're good, okay. Adding matrices. So when you add matrices, first of all, they must have equal dimensions. So you can't add a 2 by 3 matrix to a to a 3 by 2 matrix. Okay, they must have exactly the same dimensions. And so if you want to add a matrix, so say this is A, so we have -3, 0, 1, 2, and say this, we call this matrix A, okay? Plus matrix B. And I know some of you know how to do this on your calculator already. I'll show you at the end of the period. 2, 1, -3, and 5 equals what? And so all you have to do for that is add up the elements. Okay? So -3 plus 2 gives you -1 goes there, and 0 plus 1 is, so you add up the corresponding add corresponding, meaning the ones that are in the same row and column, add corresponding elements, and -1, 1, 1, -2, and 7, and so A plus B is equal to that matrix right there, which we'll call C. Okay? Questions about that? So you might use that in real life, like maybe you're adding up baseball statistics or yardage gained by football players or something like that. You know, so if this is, you have 4 different players, maybe this is their, I don't know, passes caught, yards gained, you know, something, you know, tackles, whatever. If it was this yards gained, that would be the Broncos last night, right? So anyway, they had negative points right from the gun. Okay. Can it used by adding corresponding elements? They do that. Scalar multiplication. So scalar multiplication, just like you're doing with a vector or something. When you multiply a vector by a scalar, meaning a number, all you do is you multiply the various elements by that number. So let's do something different. Say that A is equal to 3, -1, 0, -5, 2, and 7, right? Then 2 times A, which is what I get if I multiply by a scalar, is going to be equal to 2 times 3, which is 6, 2 times -1, which is -2, 2 times 0, which is 0, 2 times -5, which would be -10, 2 times 2, which is 4, and 2 times 7, which would be 14. So that's scalar multiplication. You just multiply each one of the elements by whatever this scalar, whatever that scalar number is. Okay? Yes? Maybe you're figuring out how many hot dogs you sold in various sections of the football game or something, right? So, and you sell each hot dog for $2. Probably more than that. And you want to know how much money it costs or something like that. Okay, what's next? Negation of a matrix is just you're just multiplying by a negative sign. So negation of a matrix, like it's really multiplying by -1. So if you have like B, not a very good B, if you have like B equals 4, -2, 1, 0, then negative B, which is called the negation of B, what would that look like?
-4 and 2.
-4, 2, -1, and 0. Easy enough? Okay. A matrix plus 0 is equal to 0. That's easy. I'm just going to write down some of the properties. So properties of matrices. You have that A plus B. These are all matrices, okay? Not just plain old letters. So that's called the commutative property, holds. So you could add in either order. Commutative property of matrices. This one, A plus B plus C is equal to A plus B. Does that look like an A? Kind of. A plus B plus C. What's that property called?
Associative.
Very nice. That's called the associative property. Holds. So again, all that means if I'm adding together. Hi there. Wait. I have to pause my recording. Got it? Moving on. We're not pausing. Okay, so CD times A is equal to C times D times A. And that's called the associative property of scalar multiplication. Taking care of property of scalar multiplication, meaning you can multiply two scalars together and then multiply by the matrix, or you can multiply by the matrix first and then multiply by the scalar. Okay? And then you have another property that says A plus the 0 matrix is equal to A. Oh, and I didn't really talk about that. A 0 matrix looks like any matrix that has all zeros in all the rows and all the columns. So the 0 matrix, that doesn't just mean the number 0. It means a matrix that has all zeros as its rows and columns. Okay? And sometimes it's useful to do that. And then the last two are the distributive property, which you probably know looks like C times A plus B is equal to C big A plus C big B. So if I multiply the sum of two matrices by a constant, which is what a scalar is, then that's equal to, if I multiply the first matrix by C and then the second matrix by C and then add them together. And that also works in reverse, right? So I can go like C plus D times, wait, did I write down the same thing twice? No. C plus D times A is equal to, what's that equal to?
CA plus DA.
That's equal to CA plus DA. Yeah, CA plus DA. And that's also, whoops, little d, sorry, little d, where C and D are constants. So these are scalars. And that's called the distributive property. Okay? And then, so you should be able to do something like, if I had something like A, we're doing little simple 2 by 2 matrices, so I don't have to write down a bunch of numbers. We have A equals 2, 5, 1, 0, and B equals 4, -1, 2, 5, and they asked you to do 3A minus 2b. Could you do that? Could you do that? So all you have to do is take that first matrix, multiply it by 3, that's negative 6, and 15, and then 3, and 0, minus, or you can add the negative, doesn't matter which way. The clocks are all messed up today, so 8, negative 2, that's 4, and 10. And then you could just subtract them. Minus 6 minus 8 gives you negative 14. 15 minus 2 makes 17. 3 minus 4 makes negative 1. And 0 minus 10 makes negative 2. Questions on how to do that? Really easy so far, right? Really easy so far. And then lastly, solving a matrix equation. So solve a matrix equation. So if you have a matrix equation with something like 3x plus a equals b, and this is a matrix, you solve it just as if you were solving an algebraic equation, except your answer is going to be a matrix. So if you have 3x plus a equals b, the first thing I would do is what?
Subtract a.
Subtract a. So you get 3x equals b minus a, and then I could divide by 3 or multiply by 1/3, which is the same thing. Okay, so I'm going to get that x is equal to 1/3 of, so you can do it like this, matrix O of b minus a. And so we'll do one, so in a second. So say, for instance, I have that a equals 2, 3, 5, negative 2, 5, negative 2, and b equals 5, 4, 2, 1. 5, 4, 2, 1, and you want solve for x. Solve for x if 3x plus a equals b, right? So so we already figured out that x is, so this is the same equation. So x is b minus a times 1/3. So I'm going to go 5, 4, 2, 1, right? That's b minus 2, 3, 5, negative 2. And I'm going to multiply that by 1/3, right? Yes? See what I did? So I'm using this right here. So I get 5 minus 2, which is 3, 4 minus 3, which is 1, 2 minus 5, which is negative 3, and 1 minus 2 makes what? What goes here? 3. And then I'm going to take that matrix and multiply it by 1/3, which gives me what? 1/3, negative 1, and 1. And that would be your x matrix. Did I go too fast? Did I? 1 minus negative 2. You want to know how to do that on your calculator? But you have to do these by hand, but it says...
How many times can you use the calculator?
Many parts of it, okay? So, but I want you to check. So say I was doing this on a calculator. You guys know how to do it?
Yes.
Okay. I'm going to show. Who doesn't know how to do it? Oh, I think you're so smart, aren't you? Okay. Well, let me just review. Okay. Anyway, So you go to your calculator and go into our calculator eventually. There we go. You always incorrect. And then I'm gonna close that. All right. So first thing you would do is you go to matrix, which is up here, second matrix, and you go up to edits. First, if you want A, you'd have to go up to edit and change the dimensions of A to a 2 by 2 matrix. Okay, 2 by 2. Okay, and then you're going to put in the numbers, and that's pretty easy. So A is just 2, 3, 5. All you do is go and put them in -2. Tell me if I mess up. I think I'm so good so far. And then you're going to go second quit, and you're going to go to second matrix B. Oh, first you have to go to edit, I think. No.
Yeah.
Matrix B. There you go. Matrix B. And that, you want it to be a 2 by 2 as well. 2 by 2. And you're going to put in the elements into that one, which is 5, 4, 2, 1. 5, 4, 2, 1. Okay. And then then I'm going to go second quit. And then I want to see if I got my answer right. So I'm going to go to, I wanted to get 1/3 of B minus A. Okay. So I'm going to go 1/3. Whoops, that's not a 1, that's an E. Okay. 1/3 of, in parentheses, and then you go to second matrix. Oh, no, I did that right. Matrix B, guys, minus second matrix A. Okay, close my parentheses, and hopefully I get the same answer I got over there. Hey, I did it right. 1/3, -1 and 1. Okay, so that's how you do. And that becomes really good for when you're finding inverse matrices and multiplying matrices and stuff like that. But for right now, this stuff's pretty easy to do. Okay? So your homework is page 527 on my website. Page 527. And it says check with your calculator. It doesn't say do with your calculator. It says check. So you're expected to do these by hand. 1, 2, 9, 10, 12, 13, 16, 20, 21 through 21 through 23, 25. You could always look at my website. I even have tomorrow's assignment posted. I'm way ahead. 26, 30, and 31. Okay? So that's it. And I guess we're about done. And that only